Okay, hello everybody. I'm going to talk about web application firewall as my part of the presentation for the group. So this is just going to be a pretty basic introductory. So for the people, especially those who work for like FireEye and other security company, yes, feel free to point out anything that I'm incorrect. But hey, I'm not physically here, so maybe next time when I come back, you can tell me about my mistake. So understanding the problem. So in cloud computing, we know that all our application resides on virtual environments, and they're often protected by virtual firewall. And in AWS case, it's called like a security group. And so security group are stateful, meaning that if you block a certain range of IP, then it will both block inbound and outbound. If you allow an IP to open, then it will also apply for both inbound and outbound as well. So virtual firewalls are very similar to traditional network firewall, which are layer 3 firewall basically, and it operate mainly on source IP address. So they're not very good at stopping HTTP flood or slow loris and like similar type of DDoS. And so basically, as a whole, network firewall and IDS and IPS are good at catching illegitimate traffic and provides network level security, but they're not very good at stopping cross-site scripting, injection, and other basically inherent vulnerability that comes from the web application itself. So especially when it comes to scaling, if you scale like hundreds of application on virtual environment, and some of these applications could be like legacy and older app that are not very safe. So WAF, web application firewall, would be really good in like helping in that scenario. An overview of WAF. So web application firewall is considered a layer 7 firewall as it sits right in front of the web app itself. It examines incoming traffic and verify it against its policy. So there could be a couple type of policy. There could be like a blacklist policy, which means that it will block bad requests that match that policy. There could be like whitelist policy as well, which means only good requests can go through, like requests that follow the whitelist, or you can have a mix and match of these two. Okay, so this diagram is like a very old diagram. Everybody must have seen it before. But so this is like a diagram of a traditional network-based firewall where like good user can go in, bad user gets stopped, and also there's host-based firewall that you can put on the host as well. Now let's talk about web application firewall. So this firewall would like sit behind the network firewall, and basically it would scale better because it's scaled with the app, and then it basically augment existing network firewall functionality. And some people would call it a reverse proxy because you can see like bad traffic just got bounced away. Okay, so there's a couple type of WAF. So there could be a network based, which is kind of like a physical box essentially, and it's installed locally. So the good thing is that it has lower latency because it's like physically close, right? But it requires some maintenance because it's a physical box. And we also could have like host-based WAF, but this basically would like think about if you have like groups of network, and then like these would sit with those like subnet, right? So since it's even closer to the host, and so lower latency, but then more maintenance because there could be more of them. There could be like a bunch of them, right? So lastly, we could have like cloud-based or software as a service-based WAF, and so basically these are distributed with each app, so it will scale a lot better and hopefully cheaper. For cloud-based WAF, so I basically use an example from Signal Science, which is like it's a SaaS cloud-based WAF, and basically for their solution, there's a couple different components, right? So there's a module component which you can see here. So the module pass traffic basically and act as a gatekeeper. And agent decides on whether traffic should pass through or not. So basically, agent is the guy that makes the call, right? Like green, thumbs down, thumbs up. And it gets its data from this cloud engine. And this cloud engine basically advise the agent on what it should do and stuff like that. And so basically the cloud engine will interact with like dashboards and CM and other things that like we human could work with. So that's very similar to this basically. So like we have a module, right? The module job is to pass requests through to the agent and receive enforcement decision from the agent to like either log, block, do stuff with the request, right? So if there's no answer from the agent, it will fail open. So let's say there's a certain millisecond that you need to wait for. If it exceeds that amount of time, it will just let the request through so that it won't just like block your app, right? So the next step would be the agent. So the agent can handle really heavy load. That's what it's designed for. And then it could make quick and accurate decision locally, basically, given the information that it has right now. And basically it's provide visibility, and it look into not only the request that comes in, but also the server response and other behavior as well. So the cloud engine basically gather those information, those metadata from the agents, and then it would like correlate those attack by source, by target, and also it will compare that across company profile as well. And then it basically talk to the last layer, which is human. So the human, which is a developer and DevOps engineer, could look at notification from Slack or Datadog that feed in from the cloud engine, and then also could get insight from like CM, which is like a security information event management platform, something like that. Like so, and basically we could configure how the next round of requests would be handled from the platform as well. So like what happened if traffic is flagged? So as far as signal science is concerned, right? So if the traffic is blocked, or like it's not going to just block it, but basically it will look into the request and then try to figure out, okay, has this request from this same guy been coming in consistently? If it has, then basically it would aggregate a attack pattern from all agents. And if you think that like a certain single IP or range of IP has been doing attack, it would basically block those attacks from this subsequent IP. So basically trying to take away the weapon from the attacker. Essentially, that's what this approach is trying to do. Okay, so right, so I set up two demo. The demo actually I'm done. I did the demo with the AWS WAP. It's not the signal science. So on one hand, I have like a demo with OWASP JuShop, where basically just launch a JuShop with Docker, and then we can actually see how I can do like a cross-site injection without the WAF. And then I'm going to do one that actually has WAF, and then hopefully the demo it actually could stop that traffic. Okay, so go first. Okay, so as you can see, this is a Docker container version. So it's running on Docker. And okay, yeah, so running on Docker. And so, okay, so let's just put in iframe. So this is basically the iframe injection. So you click on it, you can see that, okay, like the pop-up box popped up, right? So that means like we are able to show this vulnerability, and then I'm doing it again on the track order. And yes, it shows up as well. Okay, so unlock that challenge, which is nice. Now let's move over to the other demo. Okay, let's get out of this one. Stop. Okay. So in this one, I have an instance that is running and is hosting the OWASP JuShop. And as you can see, this is the CloudFront distribution. So like we have this CloudFront distribution, and it's like this is domain name, and it's protected by this WAF Web ACL. So this basically is running common attack protection. So I launched this from the CloudFormation script, and as you can see, this is the attack that it protects, like XSS, SQL, role, bunch of stuff, right? Okay, so let's try that again. So I'll copy the script and let's do it. But okay, so it seems that it still pop up. But okay, so I'm going to like look into it and see why. So yeah, so it's running, these are created and stuff like that. So like what I ended up finding out was that okay, if we scroll down here, um, yeah, so as you can see, the search actually, so I think this is the way that OWASP Shop work is that you can see that it actually it truncated the. Okay, let me go back to the slide first. Okay, so what we can see from there is that we can see that OWASP Shop probably take the query parameter and then it would do its own, it formulates it differently. So that's why, as we can see, AWS WAF was not able to see anything because that URL basically is truncated from the parameter and on, so it actually didn't see anything. But like in a production environment, if that parameter comes in and it contains uh, like fishy stuff like that, like if it's a SQL injection, if it's a cross-site scripting, the WAF would stop it. So basically that's the it would basically block that request. So that's basically the demo should be. But I think inherently OWASP was like a practice tool, so it wouldn't allow me to do that. And okay, so that would be the end of my presentation. So if there's any question, please direct that to my teammate or we can talk about it when I come back. So thanks guys, thank you for your attention. Have a nice day.